can tell me. Yes. So good afternoon, one and all. Today's class we'll be discussing about the problem so-called as multi-stage graph problem. Okay. So what is this problem? So as you can see, there is something called as a graph. So definitely there is a problem dealing with graph, and there is something called as a stage. So I can just tell now the graph is divided into stages. So what is that? We will see, and then we will see what is that problem related to multi-stage graph. First, let me tell you what is multi-stage graph. So very simple. It's again a directed graph wherein you have the nodes divided into set of stages, right? So they are divided into set of stages. So for example, 5 stages or 4 stages or 8 stages, some stages, wherein there is a convention that the edges in the graph are supposed to move from one stage to the next stage only. Means to say, you cannot have the edges between the vertices in the same stage. Hope you are all getting. So one stage to the another stage. It is something like you moving to one semester to the next semester. So not you will not come back to the same semester again, isn't it? So what the edges will be moving from one stage to the next stage only. So in other words, there is no edge between vertices of the same stage. Yes, and also from a vertex of current stage to the previous stage. So there is no edge from the current stage wherever it is to the previous stage. Say for example, there is a vertex in stage 3. So there cannot be a edge from stage 3 to stage 2 vertex. Whereas you can have a edge from stage 3 to stage 4, but not between the same stages too. Are you understanding? So when we talk about the definition of a multi-stage graph, it's very simple. A graph G equals to V comma E, where V is the vertices, E is the edges. They are the sets, isn't it? Wherein the V is divided into number of disjoint subsets, right? K into K disjoint subsets. Why am I telling disjoint subsets? Because the vertices in every stage, isn't it, are unique, right, compared to the other stage. They are the number of disjoint subsets K. And you all know that now K is the one which indicates the number of stages, right? Disjoint subsets S, where S is equal to S1, S2 to Sk. See, all this S1 will have the subset of vertices wherein it is belonging to stage 1. S2 belonging to stage 2. Similarly, till Sk, where Sk will have all the vertices belonging to kth stage. Are you all understanding? So the V is divided into K number of disjoint subsets, where S is equal to S1, S2 to Sk, such that every edge U comma E in E will be U belonging to S of I and V belonging to S of I plus 1. So U belongs to the set belonging to the stage Si and V belonging to the subset or the stage S of I plus 1. Means to say next stage alone. So it is not to the same stage or to the previous stage. Are you all understanding? And remember that the first stage and the last stage. See what I did? The cardinality of the subset S1 is equal to cardinality of the subset Sk is equal to 1. What does this indicate, students? Any idea? What does this indicate if I write cardinality of S1 and cardinality of Sk equals to 1? What does it indicate? The number of vertices in stage 1 is how much? Number of vertices in stage 1, students. Students, can anybody answer me? Cardinality of S1 means what? The number of vertices in the subset S1. One indicates what? The stage. So in the first stage, how many vertices will be there? Can anybody answer? Looking at this. How many vertices you have in stage 1? Students, cardinality of S1 equals to 1 means how many vertices you will have in stage 1? Can anybody answer me? Nobody is there in the class? Yes, 1. So number of vertices in the stage 1 will be 1. Similarly, number of vertices in kth stage. What is your kth stage? The last stage. The last stage also it is 1. So first stage and the last stage both will be having only one vertex. Are you understanding? Okay. And you might ask me, how do I number the stages? The stages will be numbered in the direction left to right. So left will be the first one, right one will be the last stage. Are you understanding? And the vertex that belongs to the first stage, say I say there is a vertex S belonging to S1, that is the first stage, it is called as the source. And the vertex that belongs T belonging to SK, the last stage, we call it as sink. Are you understanding? So what is a multi-stage graph? It is nothing but it is a graph, directed graph, where the vertices are divided into stages, wherein the first stage has got only one vertex called as a source. The last stage also has one vertex called as the sink. You have to remember this. And the edges will be framed in such a way that they move from one stage to the next stage, not to the same stage or not to the previous stage. Okay, and this multi-graph will also be a weighted graph. Okay, it is a weighted graph, usually weighted directed graph, wherein the cost of every edge is represented by A of I comma j. So I write the cost of the edge A of I comma, sorry, cost of the edge I comma j as A of I comma j. Okay, and if I ask you what is the cost of the path from the source to sink T, so you should understand what is the source and sink nodes are. Source is the node at the first stage, sink is the node at the last stage. So if I ask you what is the cost of the path reaching from source to sink, it is the sum of the cost of the edges in the path. So this is just telling you what is a multi-stage graph, and an example I am just giving you. You can see this graph now. It is a multi-stage graph. Just observe. Now you can see how many stages we have, students. Just see how many stages we have in this graph. Can anybody guess how many stages, students? Can anybody tell me how many stages we have in this graph? Speak out. How many stages? Just observe the
Five,
edge.
ma'am.
5 stages. You can see this is one stage. This is one stage, right? See, the stage 1 has got only one vertex, which is called as the source. This is stage 1. So I name it as V1. Stage 2 vertices, it is V2. Stage 3, V4, sorry, V3. Stage 4, V4. And this is V5. And observe there's only one vertex at the end, which we call it as sink, named as T. T and S. And you can all observe the edges are weighted, they are directed, moving from one stage to another stage. You can observe here 1 to 2, then 2 to 6. Nowhere there is an edge from the same stages, and nowhere from current stage to the previous stage. There is no edge from 6 to 4. No. So like this, you will have the multi-stage graph. So here we can observe the vertex V is divided into 5 subsets, I can tell, or 5 stages: V1, V2, V3, and V4, V5. And you can see the cardinality of the first subset V1 equals to 1 always, which contains the source vertex S, and that is vertex 1. Similarly, the cardinality V5 is 1. It contains the vertex 12, which is a sink vertex. So named it as T. So ST is a common, what do you tell, the terminology is used for source and the sink. Now you can now think, what is the problem now? What is this multi-stage graph problem? You now know what is multi-stage graph, right? So in this example only, can you see, if I ask you what is the path of reaching source to sink, there are many paths. Many paths are there. Okay, you can observe. I can reach 1 to 4, 4 to 8, 8 to 10, then 10 to 12. So many paths are there from reaching from S to T. Now, can anybody just guess what is this multi-stage graph problem? What is this multi-stage graph problem? So, if I tell you what is a multi-stage graph problem, the multi-stage graph problem is nothing but finding the path of minimum cost from source to the sink node in the graph. That is the multi-stage graph problem. So if I give you this graph, I'll have to find out the path from S to T, right, which gives me the minimum cost. Minimum cost, you will have so many paths, students. Out of that, you will have to find out the minimum cost path. And you can observe here, I have found out the minimum cost of S to T with a length of 16. And how is that? You can just observe the dotted lines. Shortest path reaching source to sink. You have 1 to 2, 2 to 7, 7 to 10, 10 to 12. Can you observe this? Yes. So reaching source to the sink node. And the path length is now how much? 16. There are so many paths. You can check. There are so many paths. Out of that, this is one. This is the shortest path. Might be there is some more, some other path. Some other path using the same length, but you can see this is one of the shortest path. I understanding. So my multi-stage graph problem is to find the shortest path distance from source to the node, sink node, S to T. I understand. So to do this problem, there is approach is dynamic programming, and they use two algorithms. One is forward approach and the backward approach. Okay. So you have to know both the algorithms. So most of the time they will ask you solve the multi-stage graph problem. You can use any one of the algorithm, right? Specifically, if they ask you, then you will have to use the specific algorithm. It's slight difference, that's all. Much no difference is there. So let me just first tell you the algorithm and then solve the problem. Then only it will become easier. Okay. So first I'll tell you the forward approach algorithm. Okay. So why this is called as forward approach? I'll tell you when I'm solving the problem there. Then only you will understand. So the algorithm goes like this. The same procedure I will write even in the problems. That's why I'm giving you the algorithm first. G is a graph, the multi-stage graph. N is what, ma? The number of vertices. What is A? A is your cost adjacency matrix, which holds the weights of all the edges. What is S? The source vertex. What is T? The sink vertex. So these are the parameters. So along with this, in the algorithm, I'll be using two arrays. One is C, one is P. One is C, the other one is P. Okay. What is the C? C array is a one which denotes the cost of the path reaching the vertex from any vertex, whatever is the vertex, to the sink. Remember, C of any vertex. So C size will be, C will be of size 1 to n, whatever it is. N is the number of vertices. Okay, 1 to 5, 1 to 6, like that. Right? So C of any vertex, what does it denote? The cost of the path reaching that particular vertex to the sink node. Sink node is what? The T node. Remember. So first I'll have to initialize the C mat array. C of n equals to 0. C of n. And you all know that this n will be always your sink node. Last node will be usually your sink node. That's how we name it usually. Okay. So the last node will be your sink node. So you can see in the example here also, the last node is your sink node. So we don't name the, what do you tell, vertices haphazardly. In the order only we will maintain. Okay. The last one will be your sink node. So right now, C of n, that is the cost of reaching n vertex to the sink node, okay, is now what? 0. It is 0 right now. Then P holds the path and also initialize P of n equals to n. Are you understanding? Right? Two initializations you will have to do. After doing these two initializations, you have to repeat some task for a j variable, wherein the j variable is equal to n minus 1 to 1. So you can see I left n. The reason because I left n, because n is my sink node. I leave it. N minus 1 to 1 back. One is what? My the source vertex. N minus 1 to 1. So I'll have to repeat this. What should I repeat? For j value ranging from n minus 1 to 1, I'll have to do certain thing. What is that? Find a vertex R. Okay. There is a vertex R such that there is a edge between j to R. For every j, I have to do this. There is a, find out there is a vertex R such that there is a edge between j to R. And I'll have to find out the minimum value. A j r plus C of R. So as I have told you, A j of R will give me what? The cost of the edge JR plus CR. What is the C giving me? C gives me the cost of the path reaching the vertex R to the sink node. So I am updating the value of J in C, finding out the shortest path of reaching J to the sink node. So from J, what is the shortest path that I can take from J to reach the sink node? So how do I just find out? Find out, is there any vertex R such that there is an edge? And find out AJR plus CR is minimum. The reason because I have to use this, JR gives me the edge cost plus C of R. C of R is what? The cost of reaching from the vertex R to the sink node T. So this will give me the value of C of J. What is the C of J? Cost of reaching J to the sink node T. Are you all understanding? So here you can have, or you tell, many R vertices. So for every R, you should find out this, the cost of reaching J to the sink node via R. Very simple as Floyd's algorithm. J to the sink node via R. Out of that, you select the minimum one. Once you find the minimum, update CJ and update PJ. So how do you update CJ? CJ will be now AJR plus C of R. Whichever gave you the minimum path. Which R gave you the minimum path for reaching J to the sync node? Update it. Similarly, Pj to be updated with R. Pj indicates what? Path. That means I could reach from J to sync node via R. That's what I mean to say. So I'll have to repeat this process for every j ranging from n minus 1 to 1. And so once I've done all these iterations, the cost of the distance, that is your shortest path reaching from source to the sink, it will be present in C of S. What is the C of S? C of the source node. And you all know your source node will be 1, that is C of 1. So C of 1 means what? The cost of reaching 1 to the sync node, that is T. Are you all getting? So this gives you the cost there. After that, you will have to print the path. So printing the path, I'll come back later. Let us solve the problem and see what we can do it. Hope my PDF screen is visible. So the example here is to now find the apply forward algorithm for the multi-stage graph. This some graph we have taken, not the example which I had shown you. Some graph I have just taken here. And you can see the numbering 1, 2, 3, 4, 5, 6, 7, 8, 9. It will be in the order format only. So you do not have to worry it. So now, what are we supposed to find here? We are supposed to find the minimum cost path from S to T. So what is S for me, students, here? What is S in this graph? What is the source vertex? Which is the source vertex? Students. Which is the source vertex, ma?
1 month.
1. And which is the sink vertex?
9 months.
9. So I have to reach to 9. See, the problem is very simple. Just concentrate. That's all. Okay. So I have to do some initialization. So I should do some initialization. So I can now see n. What is n? The number of vertices. N is equal to 9, which is S. S is 1 and T is 9. And you can see the graph is divided again here into 5 stages. You can see it's a multi-stage graph. Very simple as it is. Okay. The first two initializations I told you. C of where is that? Yeah. C of n equals to 0, P of n equals to n. So you have to remember this. Okay, these are important ones. C of n, C of 9 equals to 0 means the cost of reaching 9 to 9 is right now 0. So 9 to 9 is 0. That's all. Right? Path of 9 is 9. So C of n is 0. P of n is equal to n. Okay. Now I have to iterate it now. So what is the value of j? What is the value of j, students? What is the value of j that I should start from? J equals to what, ma? What is the value of j, students? J equals to n minus 1 to 1. So what is n minus 1 in this case, students? What is j? N minus 1. What is n for me? 9. So I should start from which vertex? J value. Students. J starts from which vertex here? J equals to n minus 1 means, so I should start from which j value? In my example. In my example, j becomes what? Can anybody tell me? What happens? What is the initial value of j? Someone has to reply, otherwise I'll not move forward. j equals to n minus 1 means I should start from which vertex? J is also a vertex, isn't it? AJR, if I take, J is also a vertex, R is also a vertex. So J starts from which vertex number? Students. Okay. Tell me which vertex should I start? J equals to. J equals to n minus 1. Prakriti.
8, ma'am.
8. So it has to start from 8. 8 to 8 to
1, ma'am.
1. So I'll have to do how many iterations? 8 iterations I'll have to do. So it's easy, nothing complicated. So first one, let me take the first iteration. It's taking the vertex 8. So why I took 8? You should remember it starts from n minus 1. So sorry, n minus 1, yeah. 9 minus 1 is 8, isn't it? So I'll have to now find out the value of C of 8. What is this 8? J. Remember. So I have to update the value of C of J. C of J means J is now 8. Okay. Take now J is 8. Is there any edge present? Is there any edge present, students? Yes, vertex such that there is an edge from J. Is there an edge from moving from J vertex? What is J for me? 8. Can you observe, is there any edge moving from 8 to some other vertex? Is there any edge, students? From 8, is there any edge?
8 to 9, ma'am.
8 to 9. So we have only one edge. That means we have only one R. That is, what is that R value? 9. Are you all understanding? R value is now 9 to me. Only one I have. Right? So there is a edge from J to R. So I write A comma A of 8 comma 9 plus C of R. So I am trying to reach now 8, from 8 to the source vertex. And which is the intermediate vertex for me? 9. Sorry, I'm trying to reach from 8 to the sink vertex via intermediate vertex, that is 9. You can observe now, I write A of JR plus C of R. So R is now 9. What is A of 8 comma 9? So the weight you can observe it is 3. So write 3. And what is C of 9? You can observe C of 9 is 0. So 3 plus 0. Only one vertex I have here. So it is 3. That only is my minimum value. So updated value of C of 8, you can observe C of 8 now is only 3. If there were two edges, then out of those two, I should select minimum. Right now, there's only one edge for me. So C of 8 is equal to 3 and P of 8, you can observe that is reached via the vertex R. And what is my R? It is 9. So I write that here. So P of 8, P of J equals to R. Remember, P of J equals to R. So I'll write this. So what does this convey to me? Very simple. This tells that the minimum path of reaching 8 to the sink is 3. The minimum cost of reaching from 8 to sink is 3. And via which path I went? Via the vertex 9. I understanding. Now, the second step, which vertex should I consider? Which vertex? 8 is done. So I should go for which vertex, ma?
7.
7. Okay. Similarly, I take vertex 7. Now I update C of 7. Again, go to the figure. Is there any edge moving from 7 to any other vertex? Any edge moving from 7?
Yes, ma'am.
It is to the vertex. Which vertex?
9.
9. There's only one edge. But still, I will write again the same formula. Minimum of A of JR plus C of R. Very simple, as I've told you. I'm trying to find out the cost of reaching from J to the node sink T with A of GR 7 comma 9 plus C of 9. So what is 7 comma 9 weight? You can see it is 7, 7 plus again it is C9 0. So only one edge I have. So 7 plus 0, that is only the minimum. C7 equals to 7, T7 equals to 9. So you have to remember this. C7 minimum value you should place here. And P of J should be updated with the R value that gave you the minimum. That gave you the minimum, remember. Okay. Next I am done with 8. I am done with 7. So which vertex will I take? Next. Vertex? Vertex, which vertex? I'm done with 8 and 7. Which vertex should I take next?
6,
Similarly,
ma'am.
6. Observe 6. This is 6 for me. Okay. From 6, how many edges we have? How many edges we have? How many edges, students? From 6, how many edges we have?
2, ma'am.
2. And you can now see there are two values of R. One is 8, one is 7. Right? So you should apply twice now. So out of that, you should take minimum 6. You can observe vertex 6. Considering the vertex 6, now we have C of 6 equals to minimum of A 6 comma 7, because there is a edge from 6 comma 7 plus C comma C of 7. So here you should give R. R is now what? 7 comma A of 6 comma 8, because there is another edge from 6 to 8 plus C of 8. Now what is 6 comma 7? You can observe in the graph 6 comma 7 is 6 and 6 comma 8 is 2. Okay. So 6 comma 7 is 6, 6 comma 8 is 2. So I'll write this. And what is C comma 7? So C comma 7, where do you get? From the previous iterations. C comma 7 is 7 and C comma 8. You can observe here. C comma 8 is 3. Are you understanding? So put that. And 6 plus 7 will give me 13. 2 plus 3 will give me 5. Out of this, you should now take the minimum. What is the minimum value? 5. Understanding? So update C of 6 equals to 5. So what does this mean? From 6, I can reach the sink node with the minimum cost of 5. Via which vertex? Via which vertex? That is the vertex 8. So you should not give your 7 students. You should give which R gave you the minimum. You can observe the second one is minimum. So what is the R value for the second one? R value is what here, students?
8, ma'am.
8. So you should update P of 6 equals to 8 because it gives you the minimum path. So you can just observe if I go back from 6, right? From 6, which gives me the minimum path. You can observe to the sink node. Sink node is 9. From 6, the path will be via 8, isn't it? And the length is how much? 2 plus 3, 5. That's what we have got here. See, C of 6, 8. Understanding. So you should carefully update this. So you should know the formula A of GR plus C of R. So So whichever is the minimum, you have to update. Now 6 is done. Similarly, I have to take the vertex 5. And you can observe 5, there is only one edge to 8. Okay, 5, only one edge or two edges? Okay, so while drawing it is missed. Fine. So actually there are two edges here from 5. 5 to 8 and 5 to 7. Okay, in the diagram it is missed. Yeah, 5 to 8 and 5 to 7. Okay, so 5 to 7 I have one edge, and similarly from 5 to 8 I have one more edge. The same thing I update here, plus C7 plus C8. So I take out of these two again minimum, and you can observe the minimum value is 5 via the vertex 8. So C5 equals to 5 and P5 equals to 8. Are you understanding? Right? So this P you should update with the R, which gave you the minimum. Are you understanding? Next, after 5, I should similarly do for the vertex 4. Yes, you can observe with respect to vertex 4, you have two edges with vertex 7 and with vertex 8. And the lengths you can see 1 and 4, the edge weights 7 and 8 with 1 and 4. So vertex 4 you can see 7 and 8. So the R values will be 7 and 8, and the length, the edge length is 1 and the 4. Are you understanding? So C of 4 is equal to minimum A of 4 comma 7, 4 comma 8 plus C of 7 plus C of 8. So you have to put a comma here. Out of these two, which is the minimum you will have to find. So 8 plus comma 7 you get, and out of these two minimum is 7. That is C4 equals to 7, through which vertex P of 4 equals to 8. 8 gave you the minimum one. Are you understanding? Similarly, do with vertex 3. So I have to deal till vertex 1, isn't it? Now tell me with vertex 3, right? How many edges we have? How many R's we have in vertex 3? With respect to vertex 3, how many R?
2, ma'am.
2, carefully check.
3, ma'am.
3, right? So that's what the reason you should be careful. So what are the R's? 4, 5 and 6. There are 3 edges. So you should carefully look into it, right? So vertex 3, you can see 4, 5 and 6. A, J, R. So J is 3. Remember students, J is 3. R is whatever the edge plus C of J. Sorry, C of R. And this you will get from the previous sub problems. Are you understanding the previous sub problems? You can see this problem is dependent on the previous one. You should get C of 4, C of 5, C of 6 from the previous ones only. Again check. So you have 3 paths. You can see now. You have 3 paths. Find whichever is the minimum. So you can see the second one gives you the minimum. Via which vertex? Via which vertex? The second one is minimum. Via which vertex? Which vertex, students? 5. So you have to update accordingly. So C of 3 equals to 10 and P of 3 equals to 5. Understanding. Similarly, we have vertex 2. And you can see with respect to vertex 2, how many R's we have? How many edges? How many edges? How many edges, students? With respect to vertex 2. That is with respect to 4 and 6. Right? So 4 and 6. See? 4 and 6. This is the edge cost. And this is the cost of the path reaching from 4 to the sink node. 4 to the sink node. So you might ask me, ma'am, how are you finding? This is what the convention which is made. This is the edge weight plus the cost of reaching 4 to the sink node. The sink node is now 9 to me, 4 to 9. Okay. So again, you will find the minimum. You can see 10 comma 8 you get. The minimum is 8. Update C of 2 equals to 8. Where the vertex 6. So P of 2 equals to 6. Alright. Similarly, the last one is vertex 1. You can see you have two edges 2 and 3 with the edge weight 5 and 2. So you can just go back for vertex 1. So A of 2 comma 3 with a weight 5 and 2 and plus C of 2 plus C of 3. Right? And out of this, which is minimum, you can observe this gives me 13, this gives me 12. The minimum is C of 1 equals to 12. Right? Via the vertex 3. So P of 1 equals to 3. So you have to deal with j, that is a vertex value n minus 1 to 1. Once it is done, as I told you, which one will you give? Give me the shortest distance path. The cost of the shortest distance path will be C of S. What is S to me? C of, sorry, what is S? What is S? What node it is? What is the node?
Source node.
Source node. And in my example, the source node is 1. So the cost of uh, the minimum path obtained with respect to the source vertex, that is C of S, is the shortest path from source to the destination. Why? Because C is designed in that way. C means C of S means or C of any vertex. It is nothing but the shortest path reaching from that vertex to the destination node. That is the sync node. Are you understanding? So you can now see the C of 1 is now what? 12. That means the path of shortest path distance for the above problem from 1 to 9, because 1 is my source, 9 is my sink, will be now what? C of 1, that is equal to 12. Right? So the shortest path distance you got, so 12. But how did you reach? How did you reach to 12, to 9 via the path 12? So you have to know the path, right? So I'll have to print the path. Let me see how to print the path. Okay. To obtain the shortest path, which leads to the cost 12, use the array P as follows. So you have to construct the P array. So take an array P whose size is of length 9. You can observe it is of length 9. So P 1, 2, 3, 4, 5, 6, 7, 8, 9. And how do you fill this? From the above entries. P of 1 is 3. Then P of 2 is 6. Similarly, P of 3, 5. So whatever you have done, that's the reason I have blocked it, right? So whatever you have done, just fill it here, right? And you just print the path. So how do you print the path? First, print the source first, right? Just print the source first. That means first print 1, which is a source vertex, print 1. Then 1 arrow mark you print after that, right? Print the source first, 1 arrow mark. Then after that, print P of 1. What is P of 1, students? What is P of 1 in my graph, in my table? What is P of 1? 3. That means from 1, I move to which vertex? 3 vertex, the vertex 3. After that, I should print from 3, I went to which vertex? How do I print? Print P of 3. P of 3 is what? 5. So print that. Again from 5, where did you go? From 5, you went to 8. Print P of 5, that is equal to 8. From 8, where did you go? From P of 8, I went to 9. So print 9. And I have to stop at this point of time. The reason because I have reached the sync node. 9 is my sync node. Stop as 9 is the sync node. Hope you are all getting. So what should you do? First construct the PRA. To print the path, first print the source. After that, print P of 1. Okay, print the source first. So you can put one comma 1. After that, P of 1. Then whatever is that, keep on printing till you reach the sync node. Once you reach the sync node, stop. And then conclude your answer. Therefore, the path for reaching from S to T will be, that is 1 to 9 will be 1, 3, 5, 8, 9, wherein the path length is now 12. You can see in the figure 1, 3, 5, 8, 9. Can you just see in the figure? 1, 3, 5, 8, 9. You can see 1 to 3 is 2, 3 plus 5 is 3 plus 5 is 5. 3 to 5 is 5, 7. 5 to 8 is 9. 9 plus 3 is 12. So this is the path. 1 to 3, 5 to 8, and then 8 to 9. Can you observe? So 2 plus 5 plus 2 plus 3. That's equal to 12. Are you all understanding? Okay. So why it is called forward? Why? Because you obtain the cost path using C of 1. From source, you are reaching to the sink. That's the reason it is called as forward path. Right? So forward path. Fine. So just moving on to the algorithm for printing the shortest path. You can just say I took one variable j equals to s. Right? So what is this j ma? Some variable. It is holding what? Yes. Yes is what? The source vertex. So I'll have to print something till j is not equal to t. What is t for me? The sync node. J not equal to t. That is the sync node. Keep doing. What should I print? Print j, the arrow mark. Then update j as what? For the next iteration, what is my j? J will be p of j. Are you understanding? First print the source vertex. That's what I mean. For the next iteration, what is my j value? J value will be p of j. Yes, that's what I did here. You can observe. First I print the source vertex. Right? Here you can see. First we print the j value is now what? The source vertex. Yes. For the next one, what is that next? For the next one, what do I get? So I print yes. After that, j becomes what to me? P of 1. What is P of 1? 3. So j becomes 3 for me. So I keep repeating the step till I get j not equal to t. That is my sync. Then it will stop, isn't it? So what should I do? At the end, I should print the j, which is my sync node. I hope you are all getting, right? So this is about the forward approach algorithm. Similarly, we have the backward approach algorithm. Slight variation you can just see. This you can see the initializations. You can see there it was what ma? The initialization was what here in forward students. Could you remember in the forward what was the initialization? In the forward approach. Students, what was this? C of
N,
student.
ma'am.
C of n. C of n equals to n. Isn't it? C of n equals to 0. Sorry. C of n equals to 0. But here C of 1. So that is I am now trying to find out the cost of the path reaching from the vertex to the sink. Right? Right? And the different approach we are just trying to find out here. So I am starting from the vertex 1. That is my source vertex. Earlier we started from the sink itself. But here it is my source vertex. So C of 1 equals to 0. And earlier it was P of n equals to n, but here P of 1 equals to 1. Right? So there we started from the sink, reached source. But here we will start from the source, then reach sink. Okay, and j also you can see j was now there where n minus 1 to 1. Here it will be what? 2 to n. Are you understanding? 2 to n, right? And the r remains the same, but look at the formula what we are taking. It is not jr, it is rj now. Rj. Why? Because the edges what we were considering was forward edges in forward algorithm, but here we should now consider the backward edges, isn't it? See the diagram, you can see in the diagram that gives you clear picture. If I start from the vertex 2, which edge I should consider? I should consider the backward edges, not the forward edges here, right? From 2, I should consider the concept of reaching from 1 to 2, the shortest path, right? So slight variation you have there. You can just observe it as Rj. So there should be a edge from R to J. The rest all is the same. So Arj plus Cr. So you have to consider the edges such a way that it is Rj, right? So plus Cr. So again updating the same is the same. Okay. Wherein the cost of the distance is C of n. There it was C of S. It is C of n or C of t. Whatever you want, you can write the sink vertex. Right? And then printing the path, it's again the reversed way you are printing. From sink to source. So first you have to print which node? The what is that? Is not dr. So t. From the sink, you will have to print it to the source. Same thing again. So you can just see I have put the inverted arrow marks here because I am trying to find source to sink. So inverted arrow marks, right? So I'll just go through the backward also. It is simpler. Nothing you have to remember the formulas. That's all. Okay, the same problem I have taken, and both will give you the same answers. No different answers you will get. Same answers you will get. So while writing the edges, be very careful. See, while writing the weights also, always the weights will be closer to the edges. So that weight you consider. Okay. Same thing you can see. The same thing. So n equals to 9, s equals to 1, t equals to 9, right? And observe that c of 1 equals to 0. There it was c of 9, n equals to 0. And p of 1 equals to 1. The path of reaching 1 to 1 is 1 only, right? Then you can observe, start the vertex 2. You can observe c of 2. Which are all the edges terminating at 2? You should take. Moving edges you took in forward, but terminating at 2. We have only one edge, that is from 1, right? So you have to take that. So A of, what should you take, students, here? What should you take? A of, there it was JR. So what should you take here? What should you take? It was JR. So forward edges you took. What should you take here? The backward edges. The back edges. So what should you write here? One is what to me? R or J? Students. One is which word? Which letter? R or J? Students, reply. Is it R or J?
R, ma'am.
R. So it should be R. Okay. And this is J. R, J. Backward approach, you should take the backward edges. So similarly, from vertex 2, you can see from vertex 3 here, vertex 3 also there is only one edge from vertex 1, right? So same thing you will compute and get the things. So I have one question for you all. Just observe the vertex 4. Vertex 4, how many edges you have, ma? How many edges we have with respect to vertex 4? How many edges? Backward edges. Students. How many edges we have with respect to vertex 4? How many edges? What are the values of R with vertex 4? Values of R with respect to vertex 4. Students. Value of R with respect to vertex 4. R value. There are how many edges? Backward edges you should consider here. RJ. Isn't it? In the forward approach it was JR. Now it is RJ. What are the values of R? R is 2 and R is 3. You can see 2 to 4, 3 to 4. See, when I take this example 2 to 4 and 3 to 4, just see it is C2, C3. See, when I compute, can you see both are same, right? Both are having the values 8 and 8. So minimum of this is 8. Anyways, but what is this p value? You all know that p of j is equal to r, meaning to say that the r which gave you minimum. So which r will you take? Will you take 2 or will you take 3? So you don't tell me, ma'am, we will break the tie and take 2 because 2 is least. But you should not do that. You should take both the values. P of 4 is equal to 2 or P of 4 is equal to 3. Are you understanding? You should take both the values. And these two values, when you compute the path, then you will have two different paths because P of 4 will have two values. Can you observe? P of 4 will have two values. So you will have two different paths having the same length, right? Having the same length. So you will have to see here. Okay, I'll just the same thing happens, right? So we compute C of 5, then C of 6, C of 7, C of 8, and then C of 9. After computing, the shortest distance path is nothing but C of n, that is 12. Similarly, you will print the path now. So you can now see, observe here, P of 4 has got two entries. Two entries. So if you are going through fourth vertex, then you will have two possibilities. So you have to check, right? What do you do here? First, we will print the sync node here. Earlier it was source node. Here we will print the sync node. First we will print 9 and the inverted arrow mark. Then what do we do? Update the value of j equals to pj. So p of 9. So j is now 9 to me. What is p of 9? P of 9 is 8. Right? So p of 9 is 8. So from 9, I go to 8. Again from 8, what is p of 8? P of 8, I go to 5. Right? Then again p of 5 is 3. From p of 5, I go to 3. Print 3. Then from P of 3 I go to 1. Are you understanding? So this is how I reach the cost of the path from the source 1 to 9, which is 12. Are you understanding? So I mean to say, see, somewhere if you would have encountered here P of 4, then you would have taken two paths. One from 4 reaching 2 and the other path from 4 reaching 3. Right? So you have to consider two paths. In the above example, P4 has two entries, 2 comma 3. So this will lead to two different paths if and only if P4 was used while printing the path. So if it is not used, no problem. If it is used, somewhere here P of 4 comes to picture, then you will have to use two different paths as the answer. Students, hope you are all getting. Students, students, okay. Hope you are all getting it. You all there? Okay. So what is a multi-stage graph? Can anybody define me? What is a multi-stage graph? What is a multi-stage graph, students? What is a multi-stage graph? Definition of a graph, multi-stage graph. Students. Can anybody define me what is a